When you're working integration by parts problems, you've seen that sometimes it's necessary to do integration by parts more than once. I'm going to show you a technique that you can actually use for every integration by parts problem if you want to, but it's really especially helpful if you have to work something with repeated integration by parts. We still have to start out the same way by looking at the two factors and deciding which of the two factors we want to be u and which of the two factors we'd like to be dv. Now, some things to think about. Considerations. First of all, dv has to be something that you can take an antiderivative of. There are some situations where one of your two factors is not something you can antidifferentiate, and so that can't be dv. So the first thing you want to do is choose dv. If you can take an antiderivative of both of your factors, then the second thing you want to think about is let u be something that gets simpler as you differentiate. So when I'm looking at this problem, I can take an antiderivative of e to the x, I can take an antiderivative of x squared. So that's not the problem. Figuring out what dv is not where I want to think, where I need to focus. Since I can antidifferentiate both of those, then the next thing I want to think about is choosing u so that it's going to get simpler as I differentiate. So I want to let u be x squared and dv be e to the x power. Now here's how I'm going to organize this. I'm going to make a table. And at the top of the table, I'm going to put u on the left side, dv on the right side, and then write down what I've chosen for u and what I've chosen for dv. Now take a derivative of u, take an antiderivative of dv, and then you do it again. Derivative of u, antiderivative of dv, and you can actually keep going until you get 0 for your derivative. This won't always happen, but in a lot of situations it will. Alright, now we're going to draw some arrows to help us stay focused and keep organized. Diagonals from the u column to the next lowest line on the dv column, and then a horizontal across the bottom. We're going to start with labeling the first arrow with a plus sign, and then alternate after that. And we're going to multiply the diagonals. And integrate the horizontal. So our integral will be x squared times e to the x. Okay, that's looking at the first diagonal. And then we come down to the second diagonal. We're going to have minus 2x e to the x. Come down to the third diagonal, and we'll have plus 2 e to the x. And then the horizontal, focusing on that horizontal line, then we're going to subtract the integral of 0 times e to the x, okay, which is that's just the same thing as 0 times anything is 0. And now you kind of have to think about, working that integral. Well, what is an integral of 0? What is an antiderivative of 0? What function can you differentiate and the derivative is equal to 0? And the answer to that is it's a constant. So anytime you have the bottom horizontal line like that, that's always going to be your plus c. You don't actually have to write the integral because it's when you integrate 0, it's always going to be the constant. So here's our integral. Now, like I said, not all integration by parts problems are going to result in you arriving at 0. So let's look at a different problem. We have an integral of e to the 6x times cosine of 4x. So I'm going to set this up the same way with my table. Okay, now this time it's not going to matter really at all which part we choose for dv or which part we choose for u. You're going to be able to anti-differentiate either of those factors. You're going to be able to take a derivative of either of those factors, and in this case, neither one of those factors is going to actually simplify as you differentiate. So just whatever you want to do. I'm going to go with e to the 6x power as u and the cosine of 4x as dv. So I'm going to differentiate. Anti-differentiate. Do it again. Anti-differentiate. Now I'm going to stop right here. Here's why. If I think about multiplying that horizontal, I'm going to have e to the, never mind the constant right now, but I'm going to have e to the 6x power times cosine of 4x, which is what I had in the original integrand. So either you're going to differentiate until you get something that goes to 0, or if you've got a problem like this, you stop when you get a repeat. So when your antiderivative or your derivative, if you had it set up the other way, goes back to cosine, you stop and take a look at what you've got. I would recommend, even if you think it's silly, always draw these arrows. It is very easy to get sidetracked and a little confused. Label your arrows with the pluses and minuses. Again, it's very, very easy to make a mistake if you don't have all this written down. So now we're looking at the integral of e to the 6x power times cosine of 4x is equal to the product of e to the 6x and 1/4 sine of 4x. Okay, and then I'm multiplying, I'm going to take minus, and then I'll have 6/16 e to the 6x cosine of 4x plus the integral of negative 36/16 e to the 6x cosine of 4x. Okay, now I'm going to clean up what I've got. Oops, dx equals, there we go, 1/4 e to the 6x sine 4x, that's a 4. Okay, minus, I'm going to reduce that fraction, 3/8 e to the 6x cosine of 4x. Minus, I'm going to pull the coefficient out in front. Let's see. That fraction will reduce to 9/4 times the integral e to the 6x cosine of 4x. Now, notice, we have an integral of e to the 6x cosine of 4x, And we have an integral of e to the 6x cosine of 4x. I'm going to add 9/4 times the integral of e to the 6x cosine of 4x to both sides of this equation. So that coefficient here is a 1. You can think of that as a 4 over 4. So 4 over 4 plus 9 over 4 gives you 13 over 4 times the integral of e to the 6x cosine of 4x dx equals the other two terms on the right side. 1/4 e to the 6x sine of 4x minus 3/8 e to the 6x cosine of 4x. Okay, and again, what we're trying to do is solve for the integral of e to the 6x cosine of 4x. So we want to multiply both sides of our equation by the constant 4/13, giving you 1 times the integral and we'll have 1/13 e to the 6x sine of 4x minus 3/26 e to the 6x cosine of 4x. All right, and let me double check with what I got before to make sure I didn't make any careless mistakes. Yep, that looks good. Now, don't forget plus c. It's real easy to get so caught up in all the relatively difficult work you're having to do here that you forget your little constant of integration, and that will be wrong. Anytime you have an indefinite integral, you've got to have the plus c.